Alright, so we're going to take a look at this transition metal nomenclature right now. Transition nomenclature is almost the same as what we were doing the other day with the single binary nomenclature. Um, Same kind of rules apply. Our cation will come first, so your metal comes first, and you don't change the name at all. No name change. So, copper will always stay copper, gold will always stay gold. And then the anion does have a name change. It'll have the IDE ending. So sulfur will become sulfide, fluorine, fluoride, that kind of deal. The only difference is, though, that we're going to have to incorporate a Roman numeral in the formula. Okay, so we're going to have some kind of Roman numeral in our formula. And we'll see what that means in a second. Okay, so pause the tape now. You can jot down what these Roman numerals are. So 1 equals I, 2 equals double I. You can just pause this and jot those down. So I'm going to go ahead. Common transitional metal cations, here they are. You might notice, if I grab my pen here really quick, um, we have iron plus 3, okay? If I want to convert that into a name, I'll have iron with a Roman numeral 3. If I have iron plus 2, I have a Roman numeral 2. If I have, copper 2, different element now, still plus 2, so therefore it still has this Roman numeral 2 right there, okay? Copper plus 1, it has a Roman numeral 1, okay? So the charges of these ions, these plus 3s, plus 2s, they are associated with the Roman numeral itself, okay? Don't confuse that, okay? The Roman numeral is the charge. All right, let's move on a little bit here. Come on, maybe. There we go. All right. So the Roman numeral is the charge of the ion, okay? Not the subscript, okay? I'm going to reiterate that. It is not the subscript. So a lot of people confuse that. They always get it wrong. So just remember, the charge of the ion is the Roman numeral. It's not the subscript. Okay. So if I have Fe with the Roman numeral 3, that means that I have Fe plus 3. If I have copper with the Roman numeral 2, that means that I have copper with a plus 2. If I have silver with the Roman numeral 1, that means that I have silver with a plus 1. Okay? I don't know why my slides are being punks, but here we go. Okay, so here's what we're going to do. We're going to practice the crisscross method with transition metals. All right? So remember that crisscross method is we're going to write down the symbols first. Okay? So you have iron with a Roman numeral 3. That means that iron is a plus 3. Okay? Then you have bromide. Well, bromide means that it's Br. Okay? Bromine, bromide, same thing. If you look at the periodic table, bromine is in group 17. Group 17, all of those elements all have a -1 charge. Okay? So they're going to be -1. All right, next part of our crisscross rule is you just write down the symbol again. This time without a charge. Oops. Why is this doing this to me? Here. You just go ahead. No charge this time. Alright? Alright, let's go ahead and change our ink. Now what we're going to do is we are going to take the numbers and we're going to crisscross them down. Okay? So the 3 comes down here. The 1 goes around down here. Okay? So we're going to have Fe 1 Br 3. Okay? Now remember, I also said that you don't have to write the 1. I'm not going to mark you wrong. You don't have to write the 1. It's not necessary. So you can instead just write Fe Br 3. Just like that, okay? And that would be your final answer. That's it. All right, let's try Let's try this one. Silver oxide. Where's my ink? Okay, we'll do this. We got silver 1 oxide, so I have Ag. That's silver. Up, so Roman numeral 1. That means that's a +1, right? Okay, I have oxygen. Oxygen. If you look on the periodic table, oxygen is in the 16th group. All of them are -2. Okay, I'm going to rewrite the symbols. Ag, NaO. I don't know why this keeps moving slides on me, but it's annoying. But we're going to crisscross these down now. Okay. Crisscross the 1 down here. Take the 2. We're going to bring that down here. This is a 2 now. So our formula is going to be Ag 2O. Just like that. Okay? That's it. That's all you got to do. Okay? Now here's where the notes comes in. Okay? There's something called the split, count, add, cancel. Okay? It's a SCAC method. This is how we're going to determine our proper Roman numeral name for our transition metal. Okay, our proper Roman numeral name. Here are the steps. Let's get this back to an arrow. Okay. Step 1, split apart the formula into a metal and a nonmetal. Step 2, count how many metals and nonmetals are on both sides. Step 3, add up the sum of the charged nonmetal atoms. And step 4, you're going to determine the charge of the transition metal by taking your sum of the charge on your nonmetal and you're going to divide it by the number of metal atoms you have. And you'll be saying, I have no idea what that means. This should be, so let's look at some examples, okay? So jot this down, pause the video if you have to. I'm going on, we'll look at some examples. Okay, so we have PbO2, okay? So our first part of our SCAC method was to split it up, okay? I have Pb, I have O2, okay? I split it. Now I'm going to count. How many do I have? This is our step 1. Step 2. Count up how many I have. Well, I have 1 Pb. I have 2 oxygen. 1 oxygen, 2 oxygen. Okay? Step 3 is count the charges. Well, Pb I don't know. That's like the whole point I'm trying to figure out here. Because I don't know this charge. So I have to leave a question mark there right now. But oxygen, we do know that. Each one of these is -2. Okay? Now, if you have 2 -2s, and you add them together, so I have a -2 plus another -2, my total answer is going to be a -4. So that means that my total charge on my oxygen side here is -4. Alright? Step 4 of our SCAC method was that we're going to take our charge, which is -4, okay, and we're going to divide it by how many metals we have. How many lead do I have? Only 1, right? There's only 1 lead in this formula. So I'm going to take -4 divided by 1, okay, and my final answer is going to be 4, okay. Well, technically it's going to be -4, but just forget about the negative, and I'll tell you why in a second, okay. Metals are always positively charged, okay, so it's actually going to be a +4 here, okay. It's going to be equal and opposite to my negative anion, okay. So I know that my lead is a +4 now, so it's not a question mark, It's a positive 4. All right, now you might think we're done, but we technically didn't even answer the question yet. I want to know what is the proper word Roman numeral name of PbO2. Okay, well, let's try to figure that out. Pb stands for lead. Okay, lead. My charge is a +4. That means that I'm going to have a Roman numeral 4, IV. Oxygen, well, I just have to change its name. So I'm going to have oxide, right? You take off the ending, the YGEN ending, and you put on the IDE. So your final answer is actually going to be lead 4 oxide. Now, this might seem like it takes a while, but over time, you'll just be able to recognize this. You won't ever have to use the SCAC method again. Okay? But for now, we'll just keep practicing with it. All right, let's try another one. Zinc 3 phosphide with a 2. Okay? So I have zinc, phosphide. Zinc with a phosphide. Let's try to figure out its real name. All right. SCAC method to the rescue. I have to split up my atom here. So I have Zn3. I have P2. Okay. Now I'm going to count how many I have. So I have 1 Zn. I have 1 Zn right here. I have 2 Zn. And I have 3 Zn, okay? I have a total of 3. How many P's would I have? Well, I have 2. So I'm going to put P, and then another P. Okay, 2 P's. Now I'm going to add up their charges. Well, I don't know zinc yet. Don't know these guys. Not quite yet. But P, phosphorus, is in group 17. All group 17s have -3 charges. Okay? I'm going to add up -3 plus a -3. Okay? That's going to give me a total of a -6. That's my total charge on all my phosphoruses. Okay? Now I'm going to take my last one. I'm going to go -6 divided by my number of zinc. Well, how many zinc do I have? I have 1, 2, 3. So I'm going to take -6 divided by 3. That equals 2. Okay? So all my zinc are actually zinc plus 2s. Oh, here's the key. It's +2. So I'm going to write down that I have zinc, Roman numeral 2, and then my phosphorus, but it gets changed to phosphide. Okay? And that's it. All you got to do. You can try doing these on your own. It's up to you. And if you want to, go ahead and check your answer. I'll put them up in 5, 4, 3. Pause the video now if you don't want me to reveal them. And let's check it out. Oh, maybe not. Maybe he doesn't want me to. Oh. It's not wanting to do it. Let's look. Hold on. Why doesn't this want to pop up? Oh, maybe it doesn't. Well, I'll just fill them out then. Oh, the technology. It's so good. Okay. So this one would be manganese. Oh man, I'm losing it. This thing is just going crazy. Sorry about that. Manganese 2 oxide. Okay, this one over here, this would be SN for tin. I'd bring down the 3. I'd have N with the 4. Okay, this one right here, number 3, that's going to be zinc 2 sulfide. Sorry about the spelling. It's really hard to write with the mouse. This one right here, this one's gold 1 chloride. Hopefully you were checking these before you made me put them up here. But if you need help, just come stop in after class. I'll help you out too. Let's do these last two really quick. You got copper, Cu, F, 2. Okay. And this last one is Cu, F. All right. Well, that is transitional metals. Hopefully you guys are able to understand this a little bit better. If you need more help, you can stop in whenever, and I'll be here. All right, I'll copy you later.